Hi everyone, welcome back to the Saga Tech Gate. In this video, we are going to learn about a special simulation feature in Verilog called the event data type. This is not used for designing hardware, but it's really helpful when you are writing a test bench. The event data type allows different parts of your code can communicate and stay in sync. For example, one block can wait for an event another block, and another block can trigger it. So it's a great way to control the flow of simulation, especially when you are working with multiple process running in a parallel. Let's understand how it works with a simple examples. The events are used for synchronization between two or more processes. So in test bench consists of many processes. So in Verilog, the term process usually refer to a block of code that executes sequentially in response to the some events. So statement written in the begin and end is a process. Okay, the statement written in the begin and end is a process. If there is no begin and end, the single statement itself is a process. Clear? So this event data types are used for synchronization between the two or more processes in the test bench. Clear? So the test bench contain n number of processes. We want to synchronize those processes. Then we'll use these events. So the event shall not hold any data. It won't hold any data. And also it can be made to occur any particular time, has no time duration. Clear? So it can be occurred to any particular time. And also there is no time duration for this event. Now how do I declare an event? So a named event is declared by using a keyword event. We'll use a keyword event to declare any event. Clear? So like event E1, like event E1 comma E2, like that. We can declare some events by using the keyword event. So an event is triggered by the symbol, okay, minus greater than. Clear? This is a symbol we use, minus and greater than. So that the triggering of the event is recognized by the symbol at the rate. So we need to wait to occur that event. So by using the at the rate, we'll recognize that occurrence of that events. So here are three steps. One is declaring an event, one is triggering an event by using this symbol, and also that recognized of the occurrence of that event by using at the rate symbol. Now see some simple example, then we'll get. So I'll define a simple model here. In this model, so I declare one event E1. Okay, what is the keyword here? I'll use the keyword event, then E1. Now E1 declared as a event type. Clear? Then end shall begin #10. You know that display triggering an event E1. Clear? So now how many initial blocks are there if you see here? So we have two initial blocks are there. We know that these initial block will execute concurrently and they starts at 0 simulation time. So now we have two initial blocks are there. So which one will execute first? We don't know. Okay, so it depends on the tool. So it may take this or this. Assume that, for example, it takes this initial block first. So begin. So we need this. If we enter into this initial block, we need to wait how much time? 10 minutes delay. Yes or no? So now, so we'll see another initial block. Now it should wait. Okay, till 10 minute delay. Clear? Then here, if you go to this initial block, then it also here at the rate E1. What is the meaning of this at the rate E1? We should wait until E1 has to occurred. Clear? Until event happen, okay, event E1 happen, we need to wait. Understood? But if you want to happen, we should declare and after that we should trigger by using this symbol. So now we see in this initial #10. Now we'll go to this initial block. Then here also we need to wait till occurrence of this E1. So now after 10 minutes of delay, then we are displaying triggering an event E1. Immediately by using this symbol, we are triggering the event. After triggering this event E1, after completion of the initial block, immediately we go to this initial, then at the rate E1, even after triggering this event E1, immediately will execute this display statement. Event E1 is triggered. First this display statement, clear? After that this display statement. So now here triggering an event E1 here, after triggering this event, so another here this statement, okay, execute only after occurring this event. Here we are waiting, okay, at the rate means you are waiting to occurrence of this E1. After occurring this, then event E1 is triggered. We'll execute this display statement. Clear? Understood. Now see another example here. Symbol one modular defined. How many initial blocks here? 4 initial blocks are there. Here 4 initial blocks are there. So we know that all will execute concurrently. That too, they start at 0 simulation time. So there is no delays, so they should complete in 0 simulation time also in this example. So now which one will execute first? We don't know. Okay, it completely depends upon the tool. Okay, it may take this initial block or this initial. As of now, okay, we are considering the order. Like assume that first this initial block will execute. Clear? After that, this initial, assume like that. There is no guarantee that all these initial block will execute in the same order. Okay, maybe after this, maybe this. Okay, we don't know. Assume that, for example, this initial block execute first, then display process P1, another later process P2, process P3, like that. It display like this. This is the output for this. Assume that this initial first, later this initial block, after that this, and after this. So how many? 4 display statement, the process P1, P2, P3, and 4. Now, I want to change the order of this statement. That too as per our requirement. I want to change the execution of this order. Okay, execution of this order. Clear? As per my requirement, I feel this display should execute first. This initial block will execute first. Okay, compared to these 3. Like that I want to. Okay, so I want to synchronize between these processes. What is the process term? Okay, so now already we discussed, right? So now first I want to execute this process. After that this one, like that. So now, for example, I want to execute P4. After that P3, later P2, later P1. Now this is a simple example. Now 4 initial blocks. I want to execute first this one. Yes or no? So now display the process P4. Now here I'll declare 3 events. Event E1, E2 and E3. Now for example, assume that maybe the simulator takes this first initial block. Okay. So but it should wait for to occur the E3. If I take this initial block, it should wait to occur E2. If you take this initial block, it should wait until occurrence of this E1. But if you go to the initial block, then it is display. Clear? Then we are triggering an event. Already we declared E1, E2, E3 as event data type. Now if I trigger this E1, then after immediately, so now in this initial block here, this statement, okay, at the rate E1, we are waiting to occur event E1. So after triggering this E1, immediately, then here we'll go to this block and it will execute, display the process P3, and after that we are triggering the event E2. After triggering, now here one statement here, we are waiting for event E2 at the rate E2, then it will trigger, okay, it will execute, then we are executing display process P2. Here we are triggering another event E3. Clear? Now this initial block here we are waiting for event E3, then we are displaying that. Clear? So what is the output for this? So first, this, what is the first process P4 will execute. Now we are triggering an event E1. So later, after triggering E1, so this initial block will execute because it waiting for to occur event E1. Okay, then this display statement will execute. Now again E2 will E2 triggered. Now here waiting to occur E2. Then this display will execute. Later this display. So now we are changing the order of execution. Yes or no? So we are communicating. So this initial block will communicate to like this. So what purpose we use this event data type? To provide a synchronization between the 2 or more processes in the test bench. That's it for today videos on event data type in Verilog. So we saw how events can be used to control the flow of simulation by allowing one part of the code to wait and another to trigger it. This is very useful in test benches and simulations only scenarios. So remember, events are not synthesizable, but they make your test bench cleaner and more organized. If you found this helpful, and don't forget to like the video and share it with your friends and subscribe to the Saga Tech Gate. So for more Verilog and VLSI content. Thanks for watching and see you in the next video.